Hello, good afternoon.
Good afternoon po, sir.
Afternoon po, sir.
Hello. Okay, start tayo. Okay, so it's been a while since last ko kayo nakita, no? 1 week akong wala, but I hope you still remember some of what we discussed last time. But today going forward, mas focus na tayo sa mga fluid mechanics problems. So expect more problem solving and calculations, no? Kahit online class tayo, I will try to inject problem solving pa rin. And I'll try to still motivate you to solve at your homes, no? So, pag class natin, expect na lagi kayong may papel and may calculator because we will be doing a lot of solving. But honestly, in my opinion, yung setup natin ngayon na alternate online phase, tapos yung 1 hour pa every week is online fixed, it's not really helping in subjects like fluid mechanics, no? Because distance learning talaga is not effective for hands-on courses or subjects like this. So, but we'll make the most out of it na lang. I hope nakikita yung slide na ganito. No? Hindi ko na siya PowerPoint slideshow kasi I have to switch between screens dahil ng Kahoot mamaya. No? I hope you can read the content. If you cannot read the content, just let me know. Okay? So, agenda for today would be to understand the system of measurements used in fluid mechanics problems. So, ito is more, actually hindi lang siya sa fluid mechanics applicable kahit sa iba yung courses. Next is to understand fluid pressure and its behavior. And third is to get comfortable with fluid statics and the Pascal law and its applications in fluid mechanics. Okay? So first is ito yung Kahoot number. So today is meron tayong mga class activity. Again, use your SR code as the name. No? So meron tayong class activity, may counting solving. So you will solve and then sa Kahoot nyo ilalagay yung final answer. No? So again, the purpose of this is that kasi kung merong problems, tapos magtatawag ako ng isa sa inyo, no? Most likely, yung isang yun lang yung gagawa. And medyo ano pa siya, yung tipong magugulat siya kasi hindi niya expect na siya yung tatawagin. So, dalas-dalas siya, kukuha ang papel, kukuha ang calcul, no? But the rest, parang makikinig lang. And again, I feel like pag problem-solving topics, hindi effective na pinapakinggan mo lang kung paano isolve yung problem. You have to really write it down. So this is my way of motivating you to write down every example, every activity that we do, no, para ma-practice niyo siya. Because again, before the midterms, isa na lang yung face-to-face classes natin. Face-to-face class. Next week. So kung doon pa lang kayong magsusulat ng problems, is maninibago talaga kayo sa solving. Okay? Sige ko na rin dito sa chat. Kahoot code 341094. Okay, next. Before we start again, I start with my classes with some kind of culture of caring. And excuse me. And this week is I want to share yung about sa Taal volcano na smog, no? So, umalis ako last week going sa aking work trip, wala pang smog. And then middle of the week, nabalita ako may nangyayaring smog nga daw dito. And then there was kind of like may mga hindi makapasok, may mga nagkakasakit, no? Malalim yung asthma, no? So here are some tips on how to para counter the effects of smog, no? So first is limit yung outdoor activities. So good good yung setup natin na may online class tayo. Nakakatulong siya pag tayo lumabas. Next is if near the Taal, always wear a 95 face mask. So I hope some you have your some spare N95 face mask pa na ginamit din way back before pandemic nung nagka-volcanic ashfall. Kung naalala nyo, umabot yun ng ano, nasa ano pa ako noon, nasa Alabang. Na pa ako nag-work noon and umabot talaga dun yung ashfall. So, tapos nakakaubusan pa ng N95. Kaya we were really caught off guard there. But I hope you still have some or you find some kung kailangan nyo talaga. Next is drink plenty of water para ma-offset or ma-dilute lang yung mga na-inhale yung gases, no? Sa katawan nyo para nalilinis na yung katawan nyo. And fourth is protect your eyes din. No? So, this mug, may mga chemicals yan na nakamix sa air. So, possible talaga na ma-irritate yung eyes. So, always, if you can wear yung mga safety goggles or eyeglasses when going out. Okay? But I think ngayon parang wala na rin masyado. It's good that recently umulan. So medyo na-wash down yung yung smog. But and I hope din hindi na siya bumalik. Okay, next, schedule. So I would like to give you the updated schedule. No? So last week, yung 17 and 23, hindi tayo nag-meet. Today yung 24, so we will be discussing fluid pressure. This is online. Next weekend, Saturday, is we will be discussing Pascal's law and pressure measurements. So that's our face-to-face. So ito yung medyo ano to, heavy rin to sa calculations. Next is October na. So October 1 would be an asynchronous take-home quiz. No? So about Pascal law and pressure measurements. Next weekend doon is problem solving. Both Saturday online and Sunday online din. Kaya yan maraming online is after October 8 na Sunday, October 9 na Monday is midterms week na. So I hope you will utilize next the remaining classes. So that's I think four meetings pa before the midterms para really familiarize yourself with the calculations. No? Yun, and then dito muna, hanggang dito lang muna yung schedule natin. Then I will inform you after the midterms kung paano natin siya yatak. Kasi nga, may isang topic actually na dapat kasama pa for midterms pero hindi na nakasama dito. After na siya ng midterms. So, kasi, actually pwede ko naman siyang isingit pero parang I would be expecting you na ma-absorb siya in 1 or 2 meetings which is kind of difficult din. So, imbes na ganun, I would rather move it after the midterms para mas siguro 2 weeks nyo siyang i-absorb and makakaroon tayo ng more problem solving about. Okay, okay, any questions so far? Schedule or while interactions? If mapansin nyo pala, hindi tayo nag-makeup class. Hindi rin ako pinayagan ng department pag-makeup class, which is the reason din kaya yung isang topic is move na lang after the midterms. Okay, next. Okay, we'll start with dimensions and units, no? So in your screen, you can see na length equals to 100 meters. So length there is the dimension. It's the property of the physical object that you are trying to know or you are trying to define. So in this case, we are trying to define the length. 100 meters, the 100 there is the magnitude. So that's the amount of the dimension that is the property of that is used to describe your physical object, no? Meters naman there is the units. So it is the unit of measurement that is used to describe your dimension, no? So together, yung magnitude and units, yun yung usually ginagamit natin when describing physical properties. Okay? So in terms of units, or in dimensions muna. In terms of dimensions, we have two types, the primary and the secondary. The primary dimensions or fundamental dimensions are basically your root dimensions or core dimensions that is used to describe the very basic or simple properties of matter, no, or physical objects. So you have seven physical or you seven primary or fundamental dimensions. You have length, mass, time, temperature, electric current, amount of light, and amount of matter. So, and these seven units, sa tabi nila, yan yung seven standard units sa system ng SI. Okay, so for example, sa length, you have meter, so yung mass, kilogram. So kilogram na siya, hindi siya grams yung standard. For time, it is seconds. Remember, seconds, S lang yung acronym niya. I see people using SEC. Pero dapat S lang. Temperature is your Kelvin. Electric current, you have the ampere. Amount of light, candela. Amount of matter is the mole. Okay, so these are the seven primary dimensions. Secondary dimensions naman, or derived dimensions, are basically everything else that uses those seven physical dimensions to describe their property. So dito papasok yung mga inaral natin na density, specific gravity, specific volume, no? For example, density, that is the ratio of the mass over the volume. And volume is actually basically three lengths at different directions, no? So length and mass, the relationship of length and mass are used to describe the density. Hence, density is a derived or secondary dimension. Okay, I hope you still get this. We usually have two systems to describe the units. First is the English or the USC, United States Customary System. The challenge here is yung relationships between units is very arbitrary. No, for example, 1 inch, inch to feet is what is the relationship is 1 foot is equal to 12 inches. No, tapos yung relationship naman ng foot to yard, iba rin yung conversion. Diba? So, kumbaga, parang random number yung ginagamit as a method of conversion such that you really have to memorize. Kung hindi mo siya memorize, you really have to have a conversion table at hand para magawa mo yung conversions. Metric or SI system naman is based on the base of 10. So, ito na yung from meter, multiply mo lang siya ng 10 raised to some exponent, magiging kilometer na siya, or yung gram mo, magiging kilogram, magiging megagram, gigagram, no? Just by multiplying ito sa power of 10. So, mas madali na yung conversion because you just simply base the conversion on a prefix that we will add to the primary unit. No? For example, here in the screen, I think familiar naman kayo dito sa mga ilang conversions, no? Basically, na times 10 mo lang siya. Or times 10 up or times 10 down. In terms of writing it naman, tulad nito, 1 mega ohm, you can write it as 1 mega ohm or 10 to the 6th ohm. Right? So, 1 kilogram, for example, you can write that as 10 to the 3rd gram and they would be equivalent. 200 ml naman is equal to 0.2 ml. So it's easy to convert between units, no? Pag SI, which is why SI din yung parang preferred way or method ng maraming countries na. Except of course the US, well, feeling kasi ng US, malakas sila or they are a strong superpower, kaya parang they want to keep their English unit. Keep on using their English unit. Kaya if you will observe, most of the products na US, laging English units yung gamit nila. Like ounces, pounds, feet, foot, hectares, yards, no? because parang yun yung parang they do not want to give up on the USC system, English system. Okay? Okay, so this is what I want you to parang absorb then. Unit etiquette. So ito yung mga parang guidelines on writing out, especially sa mga solutions nyo or sa mga thesis papers nyo, laboratory reports, no? Please bear this in mind. So a space is provided after the magnitude and before the units. So kung 10 kilograms yan, for example ito yung number 1 watt, may space sa pagitan. 1 kilogram, may space sa pagitan. So you do not make it one word, no? Only the number 1 is singular. So 1 watt, 1 kilogram. Pag decimal na, 0.3, may S na, seconds. Of course, pag more than 1, may S na yon, plural na, like 10 miles. For numbers less than 1, a 0 should be placed before the decimal, like 0.45 hours. No? So this is for clarity din, and a reminder dun sa nagbabasa na may decimal point. No? Kasi minsan, pag walang point, nakakalimutan, minsan yung point mo is masyadong manipis. Or hindi napapansin, kaya ibes na 0.45 is 45 hours na ilalagay. No? So the 0 is there to help the reader to help the reader see or identify yung point dun sa magnitude. Next, abbreviation of the units is capitalized kung galing siya sa name of the discoverer and special case for liters. So liters, hindi siya galing sa isang name pero naka-capital siya. No? So pag galing sa mga discoverer like Newton and Pascal, capital yung first letter. Pag remember, this is abbreviation. Pero pag hindi galing sa discoverer like pounds or for example sa SI, milligrams, hindi siya nakakapit. Kung galing naman siya sa discoverer, pero nakasulat siya as full unit or full name, hindi siya nakakapitalize kahit galing siya sa pangalan ng discoverer. For example, Newton, Pascal, ounces, or Fahrenheit. No? Full units or yung full name din ng units can be pluralized, pero yung abbreviation niya cannot be pluralized. Like for example, 1 gallon, you write it as 1 gallon. 2 gallons, may S na. Kasi full name siya, pluralized. Pwede. Kung shorthand naman, 1 kilogram, pag 2 kilograms na, kg pa rin yung nakalagay dyan. I see people na nagkakaroon dito ng S. Pati sa pounds, LBS ang nilalagay. But it should be LB lang kung pounds or kilogram lang, kg lang kung kilograms. Of course, pag binasa nyo, I mean, oral yung binasa, may S, like 2 kilograms pa rin ang basa dito, kahit kg lang yung nakasulat. Kasi plural siya. But if you write it down, wala siyang S. Okay? There should be also no space between prefix and units. For example, decimeter, walang space sa deci and no period after the abbreviation of a unit. No? For example, 2 feet, hindi mo dapat talagyan ng FT period. Wala dapat period. Unless, of course, it is the end of a sentence. So, yung period doon would be the period for the sentence and not for the unit. In correct terms then, you do not say kilo. Remember, kilo is just a prefix. You have to put something after it. Kilogram, kilometer. We don't use centigrade also. It should be Celsius. Micron is also a not formal term. It should be micrometer. And ton. Ton is not used anymore kasi there's a gray area kung English ton or metric ton yan. So it's better to use metric ton if you want to convert it to tons, which is 1,000 kilograms. 1,000 kilograms is equal to 1 metric ton. Okay? So yun. So again, I hope everyone is ready na yung tawag dito, kahot. Because the next slide, I would like you to solve for something. Yan. Okay, ito nakaset. Wait lang. Yan. So, in front of you are 12 dimensions. na nakasulat. So how many of these are correctly written based on our uh, guidelines or reminders, no? So you have, parang merong hindi naglagay ng SR sa kanilang kahon. So, kung isa kayo doon, just message me later kung kayo yon, kasi hindi ko ma-capture yung scores nyo pag wala kayong SR. So, I don't know if mapapalitan nyo pa yan, but if hindi kaya, i-chat nyo lang ako. Okay? So, how many of these terms are parang correct yung pagkakasulat sa kanila? Okay? You have 45 seconds to do it here, 40 seconds to do it, to read or to check here, and then another 20 seconds dun sa Kahoot app para i-select yung answer.
Nakamute po ata kayo, sir.
Ay, sorry. Nakamute ka. Okay, so the correct answer is 5. So, bakit 5? 12 seconds. The abbreviation per second is S, hindi SEC. Non-4 nanometers, hindi dapat capital yung N kasi sa prefix. 8 ampere. Full name siya. So tama na hindi siya capital. Pero dapat may S siya kasi it's plural. 2.4 gigahertz, wala dapat space sa gigahertz. 99 kilograms, shorthand siya, so wala dapat S. 0.5 pounds per second. Bukod sa walang zero dito sa harap, is may S tong pounds. So that's wrong. And 101 watts. Watts is a name of a person, so hindi dapat. Tapos naka-full name siya, full unit, hindi siya shorthand. So dapat small letter yung W. So the 5 remaining items, tama yung kasulat sa kanila. Okay? Any questions so far?
Wala pa naman po, sir.
Okay. This is just, actually hindi naman siya talaga fluid mechanics, but I hope this will help you in your solutions. So check ko rin yan. And in your future activities like theses, reports, be reminded of this. Okay, next tayo, fluid pressure. So this is yung related na sa fluid mechanics. So fluid pressure is basically pressure. And pressure, by definition, is the normal force exerted by a fluid per unit area. No? Again, kung ibabangga nyo to sa fluid and dynamics of rigid bodies, no? It can be, the term for them is not pressure. but it's stress. No? So, yung stress na sinasolve nyo sa mga deformable bodies nyo, force over area, is actually pressure. Pag yung object nyo is naging fluid na, hindi stress. It's called pressure, but basically the definition is the same. Force over area pa rin siya. But the area there, since fluid siya, is kind of medyo difficult lang to define because it's moving, it's fluid. No? So the unit for here is, again, force over area. So the force is Newton. The area is meter squared. So Newton per meter squared, which is also equal to 1 Pascal. Actually, ito, mali yung sulat nito, di ba? Dapat may space yung ones and PA. Kaya lang ano to? Picture kasi to. Oh, next. So common units of pressure is the Pascal. So usual natin ginagamit dyan is ito, 101.101325 Pascal, which is equal to 1 at ATM, which is the standard atmospheric pressure, no? So that's 101.325 Pascal. You will usually see this na naka-kilo Pascal, 101.325. And ito yung conversion niya sa bars. No? 101.325 din. This 1 ATM. You will also see this in different units like this sa baba. So ito lang yung mga conversion nila. So I hope you will be familiar with this kasi hindi lahat ng problem ibibigay sa inyo yung conversion. So it would be helpful if ma-memorize nyo sila. And para ma-memorize nyo sila ng madali, you really have to solve problems. Yung kasosolve nyo ng problems, lagi nyo ginagamit yung atmospheric pressure, no? Is na-memorize na rin siya in the process. Okay, I hope everyone is ready with their kahot ulit and solving. So this is solving na. Okay, so class activity number 2, the pressure in a water line is 1,500 kilopascal. So what is the line pressure in pound force per square inches or PSI? Okay, so to help you convert, dahil medyo bago pa, 1 kilopascal is equal to 20.886 pound force per square feet and 1 foot is equal to 12 inches. Okay, so you have 40 seconds to do it here and then switch ulit ako sa Kahoot app for another 20 seconds para i-select yung answer. Okay, so the correct answer is 217.6 PSI. So nakikita ko way or chance dyan na magkamali kayo is baka after you i-convert is pinili nyo na yung sagot. But remember, naka-square feet pa to, so you have to convert the square feet into square inches pa. And then you will get your square inches, pounds per square inches. No? And you should get 217.6 PSI. Okay? Any questions so far? Okay, next tayo. Absolute and gauge pressure naman. So medyo narinig nyo na to kasi ginamit natin siya na nagsosolve tayo ng problems using the ideal gas law last time. Again, absolute pressure is yung actual pressure. This is measured against absolute zero pressure, no? So ito talaga yung parang value ng pressure ng object or yung pressure na experience ng point, no? Gauge pressure naman is measurement pero relative to a standard atmospheric pressure. And while when that standard atmospheric pressure is usually 1 atm or 101,325 Pascal or 101.325 kilopascal or 1.01325 bars. No? But of course, there are some problems who would define a different standard or different reference pressure for your gauge pressure. No? So always read the problem kung meron siyang sinet. But basically, is before you solve anything, you have to convert your pressures into absolute pressures. Because yung, kumbaga, yung relative pressure is just relative to a standard. Hindi pa siya universal, no? So, hindi mo siya pwedeng gamitin into universal formulas or universal calculations kasi parang nakadepende siya dun sa uh, reference atmospheric pressure niya, which may be different for other places or other problems. Kaya first step lagi is to convert the gauge pressure into uh, absolute. And for gauge pressure, you would hear two words or two keywords. First is pwede mo siya i-refer as gauge pressure. Pwede mo rin siya i-refer as vacuum pressure. So pag gauge pressure, it means that yung gauge pressure na yon is above atmospheric pressure. So in that case, yung formula na to, gauge equals absolute minus atmospheric. If you would rearrange that, ang lalabas kasi dyan, P absolute equals gauge pressure plus atmospheric. So ina-add siya on top of atmospheric pressure. Additional siya. For vacuum pressure naman, that's PAPM minus absolute pressure. So if you would rearrange the terms to get the absolute pressure there is actually P atmospheric minus P vacuum. No? So ibinabawas mo yung P vacuum sa atmospheric and that's your absolute pressure. So how do I explain that in a different way? Ito yan. So yung red line is your atmospheric, it's more standard, it's your atmospheric pressure. The black line sa ilalim, yun naman yung absolute zero. Remember, your atmospheric pressure is yung red line. So ito yon at ito yon sa kabila. Pag sinabing P gauge, yung P gauge is actually on top of, ito yan, on top of atmospheric pressure. So i-add mo lang siya on top. So P atmosphere, P absolute, for this case is basically your atmospheric pressure plus yung P gauge on top of the atmospheric. So sum lang nila. So yun ang gagamitin mo as P absolute. This is actually parang straightforward kasi i-add mo lang siya sa atmospheric. For vacuum naman, P vacuum, siya actually is i-subtract mo dapat sa P atmospheric. So kung ito yung P atmospheric mo, and then may P vacuum ka, yung P vacuum, ima-minus mo or subtract mo dun sa P atmospheric, and that would be your P absolute. Kaya kita nyo, mas mababa yung blue line dito kaysa sa blue line doon. Okay? Kasi yung P vacuum is actually the binabawas sa P absolute. Okay? Question here. Okay, testing natin. Example number 1, a vacuum gauge connected to a chamber reads 5.8 psi pounds per square inch at a location where the atmospheric pressure is 14.5 pounds per square inch. Determine the absolute pressure in the chamber. Okay? So the keyword here is you have to know kung yung gauge pressure mo ba is i-add mo o isusubtract mo. Okay? So, pag i-add mo siya, the keyword, pag i-add mo siya, is gauge lang siya. The keyword naman, pag isusubtract mo siya, is may word na vacuum. Like this, may vacuum gauge. So in this case, dahil a vacuum gauge daw, so this is actually P-vac or P-vacuum. So you would have the idea na dapat ibabawas mo to sa P atmospheric. Okay? How do we solve this? Oops. How do we solve this? You have given a P vacuum, 5.8 psi, P atmospheric na 14.5 psi. Then hanapin daw yung P absolute pressure in the chamber. Okay, dahil P vacuum yan, you know na kailangan mo siyang ibawas sa P atmospheric. Okay? So, ito yung formula ng P vacuum. Then, if you would rearrange the terms, para nasa one side yung P absolute pressure, that's P atmospheric minus your P vacuum. No? So, straightforward, 14.5 minus 5.8 psi, you will get 8.7 psi. And that's P absolute already. Okay. So, straightforward lang. Any question?
Wala po, sir.
Okay po. So, in that case, so ito yun, 8.7 psi. Okay, so let's have another problem. Similar problem, pero kayo na yung mag-solve. So, a pressure gauge, dito naman, wala na yung word na vacuum. No? So, gauge na lang siya. So, it means gauge pressure siya. A pressure gauge connected to a tank leads 500 kilopascal at a location where the atmospheric pressure is 94 kilopascal. Determine the absolute pressure in the tank. So, I think you have 10 seconds lang to. Here, and another 20 seconds dun sa Kahoot to select your answer. Okay. Switching na sa Kahoot. Okay, so the correct answer is 594. Straightforward lang naman siya. Kasi it's gauge pressure, you have to add the gauge pressure to the atmospheric pressure. No? So that's 500 plus 94 lang. Okay, I think you have, kung marami naman tama, so I think you have a good grasp of the idea. No? Okay, next tayo, pressure at a point. If you have a point in a fluid na static I mean, hindi gumagalaw na fluid ang ating pag-usapan. Like maybe tubig sa swimming pool or tubig sa baso or hangin na still air, yung hindi humahangin, hindi nag-wind, still air lang siya. The pressure experienced by a point is a scalar quantity, and that means the value or the pressure from any direction should be the same. What this simply means is if I have a point, the pressure around it, yung lahat ng arrow na to, the pressure should be the same amount or the same value. No? So, hindi direction dependent ang pressure ng isang point. Which is what this means is naka-equilibrium siya. No? So, basta may point ka at hinanapan ka ng pressure, you do not have to worry about sa direction because the value of the pressure from any direction would be equal and be the same value. Okay? However, pag meron na tayong depth or palalim na, for example, sa isang swimming pool, the pressure ngayon of a point increases with depth because of the added weight it carries above it. No? So example, if meron kang drop of water or molecule of water or point of water dito sa ibabaw, dito sa labas, sa white area, ang na-experience lang yan is yung atmospheric pressure. Diba? Kasi hangin lang to. So, atmospheric pressure lang yan. However, when your point goes below the water, Then, aside from experiencing that pressure, that atmospheric pressure dito sa ibabaw, is meron ka na ngayong weight of water above your point na nag-exert ng pressure dun sa point mo. Kumbaga, kung may point ako dito sa ilalim, ay that point will have to carry the weight of the water dun sa ibabaw niya. Which is why it experiences more pressure. No? And the pressure it experiences is hindi lang din sa vertical. I mean, kasi di ba, from this rule, the pressure of a point is uniform at any direction. Sabihin, the pressure experienced by a point under the water, it increases siya with depth, pero at all directions, lumalaki rin siya. Okay? So the value of the pressure of a point under this is basically yung atmospheric pressure dito sa ibabaw. Dagdagan mo lang ng rho times g times h, depende kung gaano kalalim yung point mo. So yung rho times g times h, rho is the density of your fluid, g is your gravitational constant, and h is yung depth of your point from the free surface. No? Remember, yung pag-increase ng pressure due to depth, it starts from the free surface. Because yung water or yung weight ng water dito nagsisimula. As you go down, mas maraming water yung kine-carry ng point mo. Because of that then, if you would notice yung rho or yung density is constant, hindi naman siya nagbabago for the fluid. Kung isang fluid lang to. Your G is the gravitational constant, hindi rin siya nagbabago. And H lang yung gumagalaw. Because as you go down, your H increases. Which means your gauge pressure is directly proportional to the depth of your point. No? Also, kung pansin nyo dito, gauge to. Kasi, remember, may yung point mo naman dito sa taas, may pressure pa rin siya na-experience by the P atmospheric. No? So, which means yung rho GH mo na value is gauge pressure pa lang siya. Because it is measured with reference to the free surface dito sa ibabaw. So, gauge siya. So, when using it in problems, you have to convert it again sa P absolute. And you do that by simply adding the P atmospheric. So actually, P atmospheric is P absolute, is basically P atmospheric plus rho GH. Because rho GH is just the gauge pressure relative or with reference to the free surface ng water. Okay? Questions about this? So another thing to explain this, another diagram is ito. So dito pa, pag natin ito ka sa ibabaw, no? Your P is just your P atmospheric. Kasi wala ka pang water weight or wala ka pang water na kine-carry sa ibabaw mo. So P atmospheric lang yung kine-carry mo. As you go down, parang palaki ng palaki yung weight na kine-carry nung point mo. So as you go down, your P would be your P atmospheric, meron pa rin yun, pero may additional na weight of the water. And that weight of water is rho times G times H. Okay? I hope you understand this because ito yung main concept na gagamitin natin in our, maybe in the next month of our discussion. Okay? Any question?
Wala po, sir.
Okay, wala po. So because of that, let's look at this. First thing doon na nabanggit is the pressure is dependent on the depth of the water. Tapos, i-combine mo siya dun sa concept na the pressure experienced by a point from any direction is equal, is the same. Which means, kung to, lagyan ko ng red line dito, the point or the pressure experienced by any point at this depth h yan, so h, should be the same. Whether it is flat tulad nito, naka-incline man siya, or may curve, the pointing down, curve outward, nakaslant, or minsan kahit nga yung same level pero naka-point upward tulad nito. The pressure experienced by that point is the same. Kaya kita nyo dito, lahat ng points na yan equal, which is P absolute or P atmospheric plus rho GH. No? So, the value does not change kahit anong orientation pa ng point. Pero dito kasi, ang ginawang orientation is the direction perpendicular to the surface. And kita nyo, kahit magkakaiba sila ng direction ng, ng force or ng arrow, because they are at the same depth, is pare-pareho pa rin sila ng pressure. No? So that's important, especially sa Pascal's law. Pero, tignan nyo dito, anong point of Rho PHPI. So, PHPI, ito yan. Yan. PHPI. So, sa point na to, same sila ng height, di ba? Pero, if you will look at this, ito kasi mercury, yung fluid. Well, dito, the rest of the body dito, water siya. So, if you follow the formula, rho GH, yung H nila, actually the same. However, the rho or the density is different, which is why the pressure experienced by point H and point I, kahit magka-same sila ng height, is different kasi magkaiba sila ng density. So remember, yung density ng mercury, if you would remember, mas malaki siya kaysa sa density ng water. Kaya siya nagsisink. No? And because of that, the pressure experienced by H is larger than the pressure experienced by I. No? Because mas malaki yung dito, density ng mercury kaysa sa water. But for example, for the case ng mercury din to, sa part na to, then they would have the same density na, and then would be at the same height din. So, magse-same sila ng pressure. Yan. So, basically, yung G naman, yung gravitational constant, same lang naman yun lagi. So, basically, yung may impact lang talaga sa pressure mo is yung H and yung density. Kung magkakaiba yung fluid mo. But for the case na isang fluid lang yan, then H lang yung magiging parang factor for their pressure. Okay? Just don't forget na pag ipa-problem mo na siya, you would always add yung P atmospheric. Okay? Any question? Okay. So, example muna tayo for our last class activity. Okay? So, paano yung ba yung mga problems dyan? So, determine the pressure exerted on a diver 20 meters below the surface of the sea. So, assume a barometric pressure of 101 kilopascal and specific gravity of 1.03 for seawater. So, first assumption dito, remember, yung diver, we will consider the diver as a point in the water. Because, well, in reality, yung diver, hindi naman siya point lang. So, kumbaga, if naka-float siya vertically sa water, is mas malalim yung paa niya kaysa sa ulo niya. So, technically, from your rho GH, mas malaking pressure yung na-experience actually ng paa niya kaysa sa head niya. Diba? But in problems like this, we would consider the diver as a point object lang. So, isa lang yung height ng driver, no? Which is 20 meters. So, nabanggit din, may barometric pressure na 101 kilopascal, that's our atmospheric pressure, and may 1.03 na specific gravity for seawater. Okay, so how to solve that? So, given tayo ng height, ng atmospheric pressure, and ng SG. And it'd be useful to remember then that density of water is 1,000 kilogram per meter cubed. Because remember, your SG is density of your substance divided by the density of a standard, which is usually what? So, pinapahanap sa atin, the P of the diver. No? So, how do you solve that? You first get Remember, the P of the diver is yung rho GH niya, plus atmospheric. Kaya lang, hindi mo pa makuha yung rho GH niya kasi hindi mo pa alam yung rho ng seawater. No? Remember, seawater is different from yung standard na water kasi magkaiba yung density nila. And yun nga, the relationship is given by your specific gravity 1.0. So you first solve for your density of seawater or salt water by multiplying Sg by yung na standard mo na water density. So that's 1.03 times 1,000 kilogram per meter cube, then you get 1,030 kilogram per meter cube. Now that you have the density of your salt water, then you can use the formula rho GH plus atmospheric pressure to get the pressure of the diver. No? So pressure atmospheric is simply 101, kalig dito, 101 kilopascal. However, here, nilagay ko na siya as 101 times 10 to the third Pascal. Bakit? Kasi dito sa kabila, na-anticipate ko na Newton per meter squared yung kakalabasan kong unit. So para mag-match sila, is nilabas ko na yung 10 to the third. Okay? So 10 to the third Pascal, that's your P atmospheric, then you add that to rho GH of salt water. So the rho of salt water is 1,030, your G is 9.81, and your height is from the free surface is 20 meters. So if you combine these terms, you will get 302.086 Newton per meter squared. So pag combine mo itong tatlong units na to, Newton per meter squared yan. But remember, Newton per meter squared is equal to 1 Pascal. Kaya nakatulog na nilabas ko na yung 10 to the third. No? Kasi yung Pascal at yung Newton per meter squared, equal na sila. So I can combine them na directly. And if you would do that, is you would get 303.086 Pascal. Okay? Question. Parang mali yung unit ko. So, naka 10 to the third. Yes, Key. Oo, oo nga eh. Oo. Kasi kung same to, 101,000 to. Tapos yung 302. Ay, 202. So parang 101,202 Newton. Hmm. I will review this. Bigyan ko yung feedback. Parang mali. But, but, but the way of the solution is ganito dapat. I'll just check yung units ko. KPA to. Wait lang. One Newton per meter square lang. Okay, check ko to later. I'll get feedback. But the process is ganun lang. Okay? So, try natin dito. Similar way, pero iba na yung units. So, dito, determine the pressure exerted on the surface of a submarine cruising 225 feet below the surface. Assume a barometric pressure of 14.7 and the specific gravity of 1.02. Okay, so to help you is ito yung density, ito yung gravity, then ito yung conversion. Remember, naka-pound mass pa lang yan. Your pressure is naka-pound force. Kaya, may conversion dito na pound force per equals 32.174 pound mass foot per second squared. Okay? So you have 2 minutes 30 to do this and another 20 seconds dun sa Kahoot to answer it there. Okay, tama. Yung kanina, sa example, dapat kilopascal siya. So, hindi ko na dapat nilabas yung 10 to the third Pascal. Kasi kilopascal na yung unit niya. Dapat, tama. It's either kilopascal po yung rho GH para mag-match na sa P atmospheric or pinascal ko yung atmospheric. Tama. So yung kanina, naka-kilopascal pala yun. 303 Pascal, dapat kilopascal siya. Anyway, I will provide naman sa solutions yung sa mga sanloob natin, i-upload ko rin. Okay, so 2 minutes and 30 is up. So punta tayo sa Kahoot for your last problem. Okay, so the correct answer is 115 pound force. Remember, pound force per square inches. No? So, basically, rho GH, kasi lang challenge nyo dyan is no rho GH. Tapos yung pag-convert niya into pound force. So, I hope you get the idea of how to solve this. Medyo kailangan na ng practice para maging comfortable kayo sa units, no? But basically, that's it. Okay? So, any question for today's lecture? Wala po. Okay po. So, in the past week, medyo hindi ako nakapag-upload ng materials, no? So, may mga utang ako sa inyo. So, please give me until tomorrow para ma-upload lahat and ma-prepare lahat. And then tomorrow also, when we release on Monday, problem set 1. So, everything that we discussed will be in a problem set. I'll upload that tomorrow. Then, original plan po to submit it digitally until Friday. Pero parang mas maganda na isubmit nyo na sa akin ng Saturday sa face-to-face. Plus, parang nakasulat siya. So, I can also see how you solve it. No. But anyway, I will give the instructions naman bukas on kung online nyo ba siya isasubmit or papel, physical copy sa Saturday. Saturday then, that's September 30, we'll discuss again Pascal law and pressure measurements. And then after that, I will give you a take-home quiz. And then the following Sunday, you will do that take-home quiz. So, asynchronous tayo next Sunday. No? And parang ang mangyayari niyan is you will use the 1 hour to solve the problem take-home quiz. No? And submit it also after the 1 hour. Parang ganun yung setup. Okay? So, any question po? Okay, so yun lang po. So again, I'm sorry if parang medyo nawala ako for quite some time. And we'll try to makahabol naman. Yun nga, parang alam naman ng department ulit din tayo nag-start. Kaya rin may isang topic na hindi natin na isasama sa midterms. But the remaining topics, I hope you will be able to discuss and understand before the midterms. Okay. So yun lang po. So if wala ng question, I would see you next time.
Thank you po, sir.
Thank you
Thank you
po, sir.
po.